In this video, we're going to take a look at factoring quadratics when the a value is equal to 1. Let's just jump right in and take a look at a problem. Factor x squared plus 7x plus 12. So the way we set this up is with something called a diamond and a box. I know, it doesn't look like a diamond. Originally, when this was taught, it was in a textbook and there was a box around the x, so it did look like a diamond. If you want to call it x box, you can call it x box. I kind of always like the PS2 myself, but anyways, let's move on. So, the first step you want to do is you want to take that x squared and put it in your generic rectangle. And then you're going to put the positive 12 on the bottom right. So, now we deal with the diamond. So what we're going to do is take the 12, and it goes on top of the diamond, and the 7, the b term, goes on the bottom. Now we're looking for two numbers that will go on the left and the right of our diamond, or our x. And the rules are that you multiply these two numbers to get the top, and you would add these two numbers to get the bottom. So the easiest way to do this is to actually think of all the different ways that you can multiply to get 12. Sometimes, if you can't think of the answer, you can make a list. So let's make a list. 1 times 12, 2 times 6, and 3 times 4. That's all the ways that we can multiply to make 12 using whole numbers. So look at that list. Which pair in that list will add up to 7? 3 times 4. So those are the numbers that go into our diamond, 4 and 3. Now we're going to take the 4 and 3 and put them into our generic rectangle, because they actually stand for 4x and 3x. So now if you look at our generic rectangle, if you add it all together, you get x squared plus 7x plus 12. We're working backwards on how we usually use the generic rectangle to multiply things together. Now we can go ahead and figure out the outside of our generic rectangle. So we know we would have x times x for x squared. We would need a plus 3 to get our 3x, and a positive 4 to get our 4x. Now you should always double check that you've done everything right. Notice that the 3 times the 4 does give us the 12 in the bottom right corner. All you have to do now is rewrite the x plus 3 and the x plus 4 as your factors. So there you go. We've factored x squared plus 7x plus 12. But where does this factoring come from? You know what? You've dealt with factoring before. Back when you were in elementary school, all of these numbers over here, you called those factors of 12. So we're doing the same thing, we're just applying it to these algebraic expressions. So those right there, x plus 4, x plus 3, those are simply factors of x squared plus 7x plus 12, because when you multiply them together, you get the x squared plus 7x plus 12. Let's take another look at this, only this time we're going to show how to factor ax squared plus bx plus c, just to review the steps that we're taking. By the way, what I show you here will actually apply to your future when you're doing more complicated factoring and the a value isn't always equal to 1. So you start by having your diamond box set up. Next step, put your ax squared in the top left square. And you can put your c in the bottom right. Now, the top of the diamond is technically a times c. Now, for this video, a is always 1, so 1 times c is always just c. But I want you to realize in the future, when there's an a value, you're going to go a times c to get the top. And then the bottom is the b value. And then we're just looking for numbers, let's just call them m and n, such that m times n is going to equal ac, and m plus n will equal b. As long as you've got that, you can then take your m and n and fill in your box with mx and nx. From here, you just work the outside of the generic rectangle, get in your top part and bottom part, And that highlighted part, those are what become your factors. Let's jump in and try another problem. So we're going to factor x squared minus 9x minus 36. We've got our x box set up, ready to go. But you might notice that there's negative signs on this one. When negative signs are involved, it is a little tougher. I would argue that the majority of the mistakes that you make on these are going to involve mixing up your positives and negatives. So let's start with putting our x squared in the top left corner and our negative 36 in the bottom right of our generic rectangle. All right, now we are going to put negative 36 on the top, but remember that's technically negative 36 times the a value of 1. So 1 times negative 36 is negative 36. On the bottom, we have negative 9. Now, the rules are the same as the first one we looked at. We're multiplying to get negative 36. We're adding to get negative 9. Sometimes you can think of your answers here, but I'm going to show a list so that you realize anytime you get stuck, just make a list. So how can we multiply to get 36? 1 times 36. 2 times 18. 3 times what? 3 times 12. 4 times 9. 5. 5 doesn't work, but 6 times 6 does. So you can just start with 1 and just go down the list and figure out which ones work for factors and which ones don't. Here's why it's a little harder with negatives. When there's a negative number on top of the diamond, you need to think multiply and subtract. Now you're thinking this because the only way to multiply and get a negative number would be a positive times a negative. And when you add a positive and negative together, you actually kind of subtract the numbers and use the sign of the larger one. So that's why I want you to be looking at your list and you're thinking which numbers in the list will subtract to give me 9. And those would be 3 and 12. No, I'm not done yet. I like to just put the numbers first, and now I need to think back. In order to get negative 9, when I add these two numbers, which number needs to be positive and which one needs to be negative? Whatever the bottom is, the bottom meaning that 9, we have a negative 9, the bigger number has to be the same sign. So that means we would need a negative 12 so that when we add them together, we get negative 9. Now it's time to move those over to our generic rectangle where we'll have 3x and negative 12x. Now we fill in the outside. X times x is x squared. And we'd be going x times positive 3 to get the 3x and x times negative 12 to get the negative 12x. Double check our work. Does positive 3 times negative 12 give us negative 36? Yes, it does. So that means we got our factors of x plus 3 and x minus 12. By the way, if you're wondering, if you had placed the negative 12x where the 3x is, if you switch these back and forth, you still get the right answer. It would just change the position of them. All right, your turn to try this out. Go ahead and write down the problem, make your diamond box, and go ahead and factor it. Let's look at our answer. First thing you should have done is place your x squared in the upper left-hand corner and then your positive 24. 24 is going to go on the top, but remember that technically comes from 24 times the a value of 1, 11 on bottom. You might have made a list, or hey, when I think of 24, I usually think of 4 times 6 and 3 times 8 first, and 3 plus 8 is 11. Then we can take our 8x and 3x, x times x for x squared. We get a plus 3 on top, plus 8 on the left side. And just to make sure that 3 times 8 does make 24, and we can write our answer. Last problem, go ahead and write down this problem, pause the video, work it out, and then hit play to check your answer. So first thing you do is put your x squared, top left-hand corner, and your negative 30 on the bottom right. we have a negative 30 on the top of the diamond, but remember that technically came from negative 30 times the A value of 1. Positive 13 goes on the bottom. So we're thinking of something that multiplies to give us 30 and adds to give us 13. So again, if you come up with the answer, you don't have to make a list. If you're making a list and you see the answer, you can stop making the list. I'm going to go ahead and make the full list. And again, to make sure you capture every factor, I would start with 1. 1 times 30, go to 2. 2 times 15. 3 works. 3 times 10. 4 does not work. So you skip 4 and you go to 5 times 6. Once you get two numbers where the next number would be 6, which I already have, then I know I have my complete list. All right, remember, this is a negative number on top. So we need to be thinking multiply to get 30 and actually subtract to get 13. So which one do we subtract to get 13? 2 and 15. And that would lead to answers of negative 2 and positive 15. Again, I would write down just 2 and 15 and then figure out which one's positive and which one's negative. Those can go over in our generic rectangle. You can put the negative 2x in that empty square. It could also go on bottom left. It doesn't matter. You get the same answer either way. 15x in the missing one, and then we fill out the outside. X times x gives us x squared, and x times the negative 2 would give us the negative 2x, and then we have a positive 15. To double check it, positive 15 times negative 2 does in fact give us negative 30 for the last square. So our answer is x minus 2 times x plus 15. Now, as we've gone through all these problems, I realize that some of you might have noticed that the diamond alone actually has our answer each time. And that is true. But my advice, do it exactly the way I showed you every time, because as soon as that A value changes away from 1, you have to use the diamond and the box. And that's why I don't teach you to just use the diamond. That'll do it for factoring quadratics when the A value equals 1.